On average, 1 in 400 microchips made at a certain factory are faulty. The number of faulty microchips in a random sample of 1000 is denoted by X. X represents the number of faulty microchips in a random sample of 1000. We have n equals 1000, and we are interested in faulty microchips. So the probability of success is 1 over 400. Part A states the distribution of X, giving the values of any parameter. We have n, which is the total number of trials, probability of success, and then there are only two outcomes, whether the microchips are faulty or not. And these trials are independent from each other. X here follows a binomial distribution. It satisfies the condition for the binomial distribution with parameter n 1000 and p1 over 400. Part B states an approximating distribution for X, giving the values of any parameter. Binomial can be approximated by a normal distribution or a Poisson distribution. The key is to look at n when n is large. So it can either be approximated by a Poisson distribution or a normal distribution. Then we look at P. For binomial to be approximated by a normal distribution, P must be close to 0.5. P here is very small. So this binomial distribution can be approximated by a Poisson distribution. And to check, we find the value of NP. So we have 1000 times 1 over 400. This is 2.5. When NP is less than 5, we say that the approximating distribution is a Poisson distribution. Then we have Poisson distribution. Lambda, which is the parameter, is given by NP, which is 2.5. Part C, we use this approximating distribution to find the probability that X equals 4. So we have a Poisson distribution. We find the probability that X equals 4, and we have e to the negative 2.5, 2.5 to the 4 over 4 factorial. That should give us 0.134. C part 2, we find the probability that X is between 2 and 4 inclusive. This is the probability that X equals 2 plus probability X equals 3 plus probability X equals 4. Probability X equals 2 is e to the negative 2.5, 2.5 squared over 2 factorial. Probability X equals 3, we have e to the negative 2.5, 2.5 to the 3 over 3 factorial. And this is the same as what we found just now, which is e to the negative 2.5, 2.5 to the 4 over 4 factorial. Computing this, we have 0.604. Part D, use an approximating distribution to find the probability that in a random sample of 700 microchips, there will be at least 141. For part D here, n is 700, but p is still 1 out of 400. Computing NP, we have a value of 7 over 4, which is still less than 5. The approximating distribution is still a Poisson distribution where lambda is 7 over 4. And we want to find the probability that there is at least one faulty microchips. So we find the probability that x is greater than or equals to 1. Well, x from 1 to 700. We are not doing that. Use the complement rule. That is 1 minus probability x equals 0. So we are 1 minus e to the negative 7 over 4. 7 over 4 to the 0 over 0 factorial. Take note that 0 factorial is always 1. And this results in 0.826.